Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. This episode is brought to you by Acryl Data, the company behind DataHub, the leading developer-friendly data catalog for the modern data stack. Open source DataHub is running in production at several companies like Peloton, Optum, Udemy, Zynga, and others. Acryl Data provides DataHub as an easy-to-consume SaaS product, which has been adopted by several companies. Sign up for the SaaS today at dataengineeringpodcast.com/Acryl. That's ACRYL. Your host is Tobias Macey, and today I'm interviewing John Myers about privacy engineering and use cases for synthetic data and the work that he's doing at Gretel to support that. So, John, can you start by introducing yourself?
Hi, my name is John Myers. I'm one of the co-founders and CTO here at Gretel AI.
And do you remember how you first got involved in the area of working on data?
Yeah, my background is largely based with about 12 years in the Air Force. I started off in communications engineering, working on communication systems for space launch systems. And then I switched over into cybersecurity. And really my time in cybersecurity kind of necessitated working with massive amounts of data. And then as I progressed into my commercial career, I built a lot of products that were, founded on data, basically data-centric products. And then that kind of evolved into the need to apply different privacy-preserving techniques to that data so you can guarantee that, the products themselves weren't leaking any sensitive information. That was kind of the transition I made into, where I'm at today.
In terms of the work that you're doing at Gretel, can you give a bit of an overview about what it is that you're building there and some of the story behind you settled on that problem and why you wanted to spend your time and energy on it?
The creation of Gretel was really based off of the combined experiences myself and my other co-founders had dealing with data and privacy. And we've all have kind of a bit of a different way that we backed into it. But prior to launching the company for about 18 months, we spent a lot of nights and weekends kind of talking about the challenges we had working with data, being more productive with data, being able to innovate with data. And we also looked at, other industries out there, think about finance, code sharing, right? So if you look at what Stripe did for payments and you look at what GitHub did for collaborating with code, they made them engineering problems and they solved them by providing toolkits and really clean APIs for developers to more quickly work with that. And we said, well, why can't we boil privacy down to an engineering problem and be able to provide a toolkit and APIs for developers to more quickly create safe versions of data through a variety of means? That's kind of when a light bulb went on for us. We said, let's kind of go down that route and really go after the developer ecosystem and give them a toolkit they can use to implement a variety of privacy engineering techniques.
The term privacy engineering, I'm wondering if you can give your definition of it and what you see as being the kind of main scope and any particular areas of it that you're focusing on with Gretel.
I think at a high level, I view privacy engineering as basically a derivative of software engineering, data science, and data engineering that is really focused on the techniques and methodologies to take data and make it safer for consumption by a broader audience. And specifically at Gretel, what we're focused on is three large buckets of capabilities around privacy engineering. The first one being synthetic data, which is the ability to take data, train a machine learning model on it, and then create a version of that data that looks and feels like the real world data that is virtually indistinguishable, but is, safe from a privacy perspective. The other two buckets we have are what we would call data labeling or data classification, where you could quickly analyze a data set and determine any type of sensitive information that's inside of it. And then moving on from that, the ability to apply different anonymization or de-identification techniques through transformations to that data, which should be more discrete, more familiar ETL processes that you might have worked with in the past if you're previously a data engineer.
In the scope of an organization or a data team, who do you typically see as being responsible for privacy engineering or taking point on that issue?
I think it really varies on the organization. I have seen it be owned by the data owners themselves. If you think about like a large database that holds data, and you have database administrators and you have some software engineers that closely work with it, oftentimes they are chartered with being able to create a safe version of that data when requested. I have seen organizations that have a dedicated shop that is responsible for going in and applying those privacy engineering techniques. And I think that kind of question and my answer to that, somewhat highlights a bit of a problem where it's not always obvious who has that responsibility. And that's partially because there's not a lot of tools out there that enable, the developers that are closest to that data to be able to implement those privacy engineering techniques. And that's one of the things that we're trying to solve here at Gretel.
Because of the fact that there isn't necessarily a clear owner of privacy engineering as a practice, I'm curious how you see that impacting the overall adoption in organizations and industries of these privacy engineering practices and the kind of proper attention and attribution of importance to it as a first-class concern.
Yeah, so I think the lack of like a central party that is responsible for privacy engineering is one of the contributing factors to this huge timeline that has to be executed to even get access to data. So when you look at like trying to share data from one team to another or from one organization to another, one of two things has to happen. You have to figure out how to get the data into a safe state that you can share it, which would be, applying privacy engineering techniques, or you have to go through some type of approval process. So then the recipient of the data is, signed off to be able to have access to the sensitive information. And both of those timelines are very long, and it really hampers innovation. And so what I think we see with our customers now is that they're interested in adopting these tools right into their software engineering and product engineering teams so that the owner of the data, or better yet, the creator of the data, which is usually, an engineering team or a data science team, has the capability to quickly apply privacy engineering techniques and then be able to just to move that data exactly where it needs to go. So people aren't scrambling around trying to figure out, who's responsible for actually doing it. Like if you know who built the product, you should be able to ask them to do it because now they'll have the tools to do so.
In terms of the target users of Gretel, you mentioned that you're looking to be an empowering solution to make it easier for teams to be able to adopt some of these principles and practices of privacy engineering. I'm curious how you think about the different personas that will interact with the Gretel platform and how that informs the feature prioritization and the overall design of the product.
Our target user is definitely a mix of software engineers, data scientists, machine learning engineers, and researchers. And when you look at that user base and you think about the way that those personas like to adopt tools, oftentimes they want to be able to kind of jump in and get started on their own without having to kind of go through any specific onboarding process or have to, give access to like a license, like going through kind of more of an enterprise sales type motion. And so the way that really informs us on how we build is to create a very, very low friction experience, be able to sign up very quickly, and offer all the features of privacy engineering for free for anyone that signs up. They can dive in right into our console and be productive within a matter of minutes, and then have our API documentation and our blueprints and our blogs to show folks how to get to that next level. That has been the approach we have taken, really just like a self-serve model so people can get productive within minutes and scale however they need.
As far as the kind of general adoption, obviously having tools such as Gretel makes it easier, but across the industry, I'm wondering what you see as maybe the either points of friction in highlighting this as a problem that's important enough to invest in, or just the general kind of visibility and awareness of this as a problem that needs to be solved within data teams.
I think there's a couple of contributing factors there to kind of the friction points of adopting privacy engineering. One, I'll call it the status quo or the state of the art that's out there right now are kind of two ends of a spectrum. You see that there's a lot of tools that are built into cloud providers, and a lot of them are built under the umbrella of what we call data loss prevention, which has kind of been in the cybersecurity realm for several years. And so you have tools in Amazon and Google and Microsoft Azure and all the other cloud providers where they give you some privacy tools. However, they're designed to work only with the services that those cloud providers have access to. So they're kind of like, if you're really using Amazon, you get some privacy capabilities there. But if you're working in a generalized software engineering environment, you can't necessarily use those cloud provider tools unless you're really inside their ecosystem. And then on the other end of the spectrum is you have a lot of really awesome developments coming from research organizations, educational centers that are developing open source tools to enable privacy engineering. And they're all amazing and really cutting edge, but they don't come with enterprise support, commercial support for a really large company to adopt them at scale. That doesn't come with the tools you need to actually run those, right? You have their software packages, their SDK, so you're still responsible for building an infrastructure, figuring out how to deploy them, putting a service around it. And so Gretel kind of wants to be, right in the middle there, right? Like we're agnostic to a cloud vendor, we're agnostic to programming languages, we're turnkey API enabled, and so you don't have to bring your own infrastructure, you don't have to bring complex GPU systems to do the machine learning and synthetic data work. We offer it all for you. And so I think that is what is really driving folks, is that one, they don't want to be locked into a certain cloud provider for privacy engineering tools. And two, they want the ability for someone else to handle the infrastructure side of it. They want the tooling to be agnostic, a very specific type of ecosystem. So they have more flexibility to privacy engineering into many different developer workflows.
Are you looking for a structured and battle-tested approach for learning data engineering? Would you like to know how you can build proper data infrastructures that are built to last? Would you like to have a seasoned industry expert guide you and answer all of your questions? Join Pipeline Academy, the world's first data engineering bootcamp. Learn in small groups with like-minded professionals for 9 weeks part-time to level up in your career. The course covers the most relevant and essential data and software engineering topics that enable you to start your journey as a professional data engineer or analytics engineer. Plus, they have Ask Me Anythings with world-class guest speakers every week. The next cohort starts in April of 2022. Visit dataengineeringpodcast.com/academy today and apply now.
In terms of those workflows, I'm wondering if you can talk through some of the different stages of the data lifecycle that privacy engineering can and should be factored into, and just some of the process of being able to actually integrate Gretel into those inflection points of data as it's generated, manipulated, processed, incorporated into various analytics or machine learning models, et cetera.
At a general level, our philosophy about how to inject privacy engineering into kind of the life cycle of data is, ideally you can get as close as to the source data as possible to execute that, because what you run into is this amplification problem when you have data, right? And as soon as you create a data set or you populate a database, that data is going to get exported and sent around to all sorts of different stakeholders, whether it's other engineering teams, data science teams, business teams, marketing teams. And so that data is just going to be replicated over and over and over again. And so if you can kind of find that choke point where that data first gets created and into the initial, call it repository or data store, just to use an abstract term, if you can apply privacy engineering at that point, then you can create a safe version of that data. And then that amplification problem becomes less risky because you're amplifying and sharing a safe version of the data. When it comes to like specific Gretel implementation for that, for us, it's being able to kind of scale with that data creation. So we have our core APIs, which allow you to do, granular transforms on data or create a synthetic version of a data set. The APIs can also then be like wired into an automated tool, your CI/CD pipelines. We're building a suite of connectors. So you can grab data when it lands in an S3 bucket and immediately create a safe version of that data and put it into another S3 bucket. And so being able to turn this on into in a data pipeline style like that is the way that we typically integrate with our customers.
Can you describe a bit more about how the Gretel platform itself is implemented and some of the architectural and design elements that you had to consider as you were starting to build out the platform and onboard some of your early design partners?
I'll kind of start with the current state and then I'll kind of talk a little bit of how we got there. So the current state is that we offer, under the hood, Gretel is a cloud service that is backed by REST APIs. And those REST APIs let you schedule jobs, and those jobs consume input data, execute the privacy engineering tasks, whether we're doing synthetic data generation, transforms, data classification, and then they output that data. All of that can be scheduled and achieved purely with our REST APIs. And then we have different interface layers in front of it. So we have our console, which is, our flagship. You log into Gretel, you get started. That's our user interface. It uses those REST APIs for you. We have a CLI tool that you can drop into the command line and you can start to build scripts and you can kind of get more automation. And then we have language specific SDKs that allow you to kind of then bake us into, whatever software applications you have. But under the hood, the big architectural decision we wanted to make was that the API itself is what drives everything. And then we can build tooling around it for different specific types of frameworks and ecosystems. How we ended up there is really kind of our evolution through 2 public betas that we had before we went GA about a month ago. So our first beta release, we implemented and we provided SDKs that, did a lot of the synthetic data generation, transforms, and we put them out there in blueprints and we allowed people to download those SDKs and integrate them into the workflows. However, they were offered in Python. You had to put them inside of like Jupyter notebooks. And so you out of the gate for that first beta, we had, a ton of design partners come on and they loved it. But what we learned is we kind of isolated the consumption of Gretel to a narrower audience than we wanted. So we start talking to other design partners and they're saying like, well, hey, we're Java shop and we're building XYZ in Java, or we're Golang shop and we're building this. And they all have different circumstances. And so when we took a step back, we said, can we add a layer of abstraction in this REST API so that everything can go through that? And then it doesn't matter what language you write in, and it doesn't matter what framework you're on, you can integrate Gretel anywhere. And that's how we got to where we're at today.
In terms of the kind of nuance of integrating data obfuscation and synthetic data into your data sets for analysis or machine learning, or just being able to create a safe version of a data set to share with other organizations or publicly, what are some of the kind of details and nuances that you typically see data engineers or data analysts running up against, and just some of the considerations that they need to be aware of as they start to use something like Gretel?
Yeah, I think one of the biggest nuances is this kind of utility versus privacy, I'll call it trade-off or relationship. So look at synthetic data. Our synthetic data capability comes with privacy capabilities baked in, and you can kind of tune the privacy settings based off what your use case is. But if let's say you put very high privacy settings on, that might impact the utility of the data because we do certain things like go over these similar records to the training data, or we remove outliers that can potentially be used to infer information about someone. And so really what we kind of talk about with our customers is, where is this data going and who's the consumer of the data? Let's say, for example, you are replicating a database because you need to have mock data for an engineering team, and you know that a lot of engineers are going to consume and have access to that data. Then we would say, well, why don't you just turn on the privacy level as high as it can go, and then you'll have a reasonable amount of confidence that you could just make that data generally available to a lot of those developers, because they're really looking to kind of just build, let's say you're building a user interface around that data. You just want the data to fit in the user interface, and you want to make sure that your components and your interactions can be built the way they need to be built just by having access to that data. So that's like one example. On the flip side, let's say you are sharing data with a data science team and they need to train a machine learning model on that data. You have to kind of pay attention to the different configuration parameters to make sure that you don't lose a lot of the correlations and statistical properties of that data set. And if you know that data isn't going to be necessarily like shared publicly or shared very widely, then you can make some trade-offs and preserve a lot of the utility in the data and then adjust your privacy settings that way. So it really comes down to those two kind of like really big knobs. And there's a lot of micro adjustments in the configuration you can make to account for those use cases.
And as far as being able to maintain some of that statistical relevance as you are modifying or manipulating the source data sets, what are some of the ways that you have worked in sort of strategies to maybe simplify that process for end users so that they don't have to necessarily be as familiar with the state of the art of those statistical methods to figure out what is the sort of appropriate sampling and distribution of the source data sets and the acceptable mutations that can be made, and just making it as sort of plug and play as possible while giving them an appropriate level of control?
There's kind of like two sides to that. So on the configuration side, before you run like a job in Gretel, we have some high level knobs that you can turn, right? We have different privacy settings, and you can just say, you can turn them off, you can put them on medium, you can put them on high. And we try to kind of stick with those high level simple settings so people can get started very easily. And then as you kind of iterate and work with the data, you can drill down and start to like even get into hyperparameter tuning for some of the underlying models, which we start to see customers do when they really want to like hone in on certain attributes that they want the data to have. And then on the output side, one of like my favorite products that we have here is this notion of a quality report, a synthetic quality report. And what that does is that looks at the original data and looks at the synthetic data and basically gives you, some high level scores about those distributions, about those statistical properties, about kind of like the deep structures within inside of that data. And then we'll tell you like, hey, like your score is excellent. And therefore, you can use this synthetic data for machine learning, right? Like you can actually train a machine learning model on this and then go put that machine learning model and make predictions on the real world data and have the same, if not better accuracy than you would have by just building a machine learning model on the original data. So what you can do is you can kind of run experiments and tweak different configuration parameters, and then you can look at how that score changes for you, right? And that score will show you like what the privacy levels are, and it'll show you what the utility levels are. So we've definitely used some other tools like weighted biases out there as an awesome product we've integrated into some of our blueprints where we can show how to do like parameter sweeps to be able to show how you can get the right optimizations for what your desired output is. And so you basically can just watch those scores change based off of your input. And then once you kind of find that sweet spot of what you want, that's where we'll say, okay, now you can kind of start to automate us into your workflow because you know what those parameters are and you can turn us on kind of like at always on state to process your data.
For the machine learning use case, what have you seen as the kind of utility of just using purely synthetic training data sets rather than having to work from the point of having collected a set of data and just using purely synthetic data as a way to kind of bootstrap your ML operation in the case that maybe you're a new business or you're trying to develop a new model or product line and you don't necessarily have enough raw information to be able to actually do anything substantial on the ML front?
That's like probably one of the most innovative things that we see our customers doing is kind of solving that, quote unquote cold start problem where they need data, they don't have any to start with, or they have very little data and they want to amplify that so they can actually have enough to test a variety of machine learning models. So a lot of times we have customers coming to us with like some sample data, and they train the model on it and they use that model to generate, 10x, 20x, 30x the amount so they can actually experiment with different machine learning techniques for their use case. And sometimes they do have enough data, but what they want to do is it's like team one has data, they need to get it over to team two so they can train a machine learning model on it. Really, that's like a privacy gating problem, right? I can't give you access to the sensitive information, and maybe it's a third party data science team. So you can create a synthetic version of that data. And then what you can do is then just give a synthetic version to that team, let them train a machine learning model on it, bring it back in. So that's like the second use case, right? The first one, the cold start problem. The second one, like the privacy sharing problem. And the third one, which is really neat, is that sometimes you just don't have enough of certain data within your data, right? So if you have, let's say you're predicting fraud, or we have a ton of medical use cases here where there's just not enough of a certain data class that you're trying to predict on, you could actually boost certain types of data within our synthetic models. So we call that the conditioning or smart seeding capability, where you can train the model and you can say, hey, I only want you to synthesize records that have these partial values, and then we'll synthesize the rest of the record for you so you can actually boost or balance your data set.
In terms of the machine learning use case, another aspect of this that's interesting to explore is the question of bias within the generated data sets, because that's always a problem when working with machine learning or analytics, is the question of, are you incorporating any sort of statistical biases into your results based on the data collection that you've done? And I'm curious how you see people approaching that problem and potentially mitigating it when they're working with synthetically generated data sets, whether that's in terms of the types of demographic information that you're producing so that you have an appropriate range of distribution of ages or locations, et cetera, and just that overall question of artificial bias in synthetic data sets.
That is one of the biggest use cases we see for the third thing I just mentioned, where you can use our abilities to kind of define part of the data that you want to see generated. So you want to balance out, let's say an imbalance in gender or race or ethnicity or ages, and then that'll help your machine learning models actually perform better. We had a blog post previously where we took an open data set about it was like heart disease prediction, and there were twice as many male records as there were female records. And so that naturally added bias to the machine learning model because it was much better at predicting male heart disease and female heart disease. And so we went through and we synthesized more female records. We balanced out the data set. And then what we found is that we had better performance across the board on both male prediction and female prediction in that use case. So we did that in our beta 1, and we're actually re-releasing that with our new APIs here shortly.
The other interesting element of being able to synthesize or obfuscate data is the question of being able to proactively identify potentially sensitive attributes in a given record or set of records, and how you have built up your heuristics or models to be able to help your customers understand which attributes they do want to modify or mutate in their privacy engineering workflows.
When I talk about privacy risks, for lack of better terms, I'll call discrete real privacy risks. Like you mentioned, there's just identifiers that are very obvious, right? Social security numbers, email addresses, phone numbers, addresses. And then there are these aggregate risks that can be used to essentially re-identify someone, right? There are plenty of studies out there that show a zip code plus an age, could be re-identifiable, down to just one or two people in a large data set. And so a lot of the things that we've incorporated will help identify some of those risks and let you mitigate them by adding, at the synthetic data level, that is very good for solving that because it will create records that can't be re-identified back to independent users because those values are synthetic and generated, and the distributions and the correlations still hold, but we're not replaying any of those attributes at a record level, right? So, just for argument's sake, I'm the only one in Philadelphia, that's in our company. And that also shows as an outlier in the data too. And sometimes you just have to remove those. And so our synthetic data generation capability will also remove some of those outliers because reasonably you're not going to synthesize, even if you synthesize a bunch of data about someone in Philadelphia, then it's still going to be me. So we'll actually remove those from the data set. And then sometimes there's enough samples in an area where you just want to make sure that your ages are modified enough or your whatever your specific locations are modified enough. And so synthetics takes care of a lot of that automatically. Sometimes you need a more granular approach to do that. And so what we do in our transform capability is we actually have the ability to kind of, abstract ages into maybe buckets of ages or put dates into buckets of dates. And so you still get value out of the data set. It's just you remove the discrete identifiers there. So yeah, those re-identification risks are some of the ones that are a lot more subtle. And so those are the ones that a lot of our customers really want to have us take care of for them.
There are definitely some parallels between privacy engineering in the data space and security engineering in the application development and infrastructure space. One of the practices that's common there is the idea of doing, game days where you have red teams and blue teams where one person is trying to attack a piece of infrastructure or an application and the other team is trying to defend against it. And Gretel is definitely a useful tool in the defense stance. And I'm curious what you have seen in terms of the sort of availability or development of practices or tooling to help with that attack-oriented planning for being able to maybe use generative adversarial networks to automate some of these re-identification techniques and figure out how well you're able to defend against them with these synthetic data sets, or just that overall practice of sort of defense in depth or offensive tactics in the privacy engineering space.
That's a really cool corollary to kind of like the red team, blue team approach in cybersecurity. Internally, the ML team here has used quite a few frameworks to kind of, quote unquote, attack data. And then we have used those to help actually influence how we build some of the filters that we put in place to then mitigate those attacks. So when it comes from a product development standpoint, we'll be able to take a lot of sample data sets, run various adversarial techniques against it, determine that there are ways to re-identify stuff. And then, we have built our filters to then remove that risk and then rerun the attack and then show that that risk is mitigated. We're not necessarily building those attack frameworks for public consumption, but we definitely use them as part of our product engineering process.
It's definitely interesting to see how sort of the overall data ecosystem is starting to adopt some of these principles from application and infrastructure and figure out how well does it map? What are the cases where there's actually some more specific sort of nuance to it in the data space, and being able to manage those translations back and forth.
I think what would be really cool to start see is given CTFs, what does a data privacy CTF look like? A capture the flag. How could you use that to almost crowdsource certain types of techniques out there?
Also, taking it a bit further, the question of CVEs, or what are some of the known vulnerabilities in data sets or particular data modeling approaches, and how to mitigate them as you prepare your data sets for public consumption.
Yeah, that's something we've talked about. The CVE is one angle for sure. And having spent, a lot of us, especially the founders, have spent a lot of time in the government, and in the government, you have different levels of data classification, right? Confidential, the secret, the top secret, and there's all the different caveats you can attach onto those. What is that for data privacy, right? And that's something we've been thinking about. How do you put some type of classification, which is a very overused term, so it can mean a lot of things. So when I mean a classification, I mean something, not necessarily confidential, top secret, but how do you put a label, so to speak, on a data set that tells you what the reasonable shareability is of it, right? And that's something we're trying to iterate, because there's not a lot of that out there, if anything, right? And so how do you just put a simple stamp on a data set or a database that says, yep, this has been processed by Gretel, and it is certified that it could be released at this certain level of consumption with these guarantees.
To that point of safety of release, there's also the time component to it, where maybe a certain data set is only valuable or sensitive within a particular time horizon. And, after a year, you can safely release it because all of the information is no longer pertinent or sensitive. For instance, if you have a data set related to travel plans, where maybe you're working with a travel agency and you don't want to release information about when people are going to be away from their homes, in the future, but after a certain period, that's no longer valid. And so you don't have to worry about that aspect of it. I mean, there are certainly other considerations to that of, knowing what are people's travel patterns for different reasons, but the question of timeliness in data security is also maybe an interesting angle to it.
Yeah, that's really interesting to think about how that data becomes less of a risk just with the factor of time, right? In theory, you might not have to do anything. You just might say, hey, time's out. It's something that's in the past. I think kind of related to that, then you also have to think about how does a data set change, especially when so many companies are working with streaming data. Even another dimension in the data set gets added into that stream. It could drastically change the privacy risk of it when you think about re-identification attacks, right? You just add a new dimension that all of a sudden becomes, reattributable back to someone because we just added in an age column, or we just added in a city column. you might have to completely rethink about how you process that data from a safety perspective. And so how do you detect those changes over time? Something that like our classification tool is really good for. And we've had a couple of customers kind of refer to it as like a data firewall, where it's like, hey, like to use the security analogy, like you might freak out if all of a sudden you see a port open up that shouldn't be opened up. Or what about if you see like a new data element or a dimension get added that you didn't know was there? How does that change it? And so how can you say, hey, this slipped into the data stream? How do we change our privacy posture around?
Do you want to learn how the Joybird data team reduced their time spent building new integrations and managing data pipelines by 93%? Join a live webinar hosted by RudderStack on April 20th, where Joybird's Director of Analytics, Brett Chawney, will walk you through how retooling their data stack with RudderStack, Snowflake, and Iterable made this possible. Go to rudderstack.com/Joybird to register today.
Another interesting aspect to what you're saying about the classifications with the analogy to confidential or top secret or sensitive is maybe being able to use the lineage information that a lot of people are tracking in their data processing pipelines to understand what are the kind of terminal nodes in this lineage graph so that I know who are the consumers of this data set, and then being able to propagate that backwards to the earlier stages of the pipeline to say, okay, this piece of information is going to be consumed publicly. This is the inflection point at which it starts along that path. And so this is where I need to know to apply these obfuscation techniques to these records to make sure that I don't have to worry about it further down the line.
That's really interesting. It also kind of reminds me of like, there's also like the joinability problem too, where the data set on its own, you might have a reasonable expectation that it's safe, but there's entire companies that build their entire business model on like aggregating data from different sources and doing joins on it. And then all of a sudden you've taken, maybe 3 or 4 or 5 different data sets that are reasonably private to begin with, but then the rejoining of them changes, quote unquote, the classification level, right? Again, that's another kind of corollary from government where you have individual pieces, maybe you're all unclassified, but you combine a couple of unclassified things together and now you have a secret level problem. So how can you break that joinability earlier is another kind of like challenging problem to think through.
Absolutely. In your work of building Gretel and working in this space of privacy engineering and helping your customers mitigate some of the potential attacks on their data sets, what are some of the most interesting or innovative or unexpected ways that you've seen Gretel applied?
I think kind of revisiting some of the stuff we mentioned before, some of the cold start problem have been really interesting, where you look at, let's say, a company that wanted to move into a different market from a sales perspective, and they wanted to kind of model like, hey, what would the sales information look like in this market? It's almost like a extension of like transfer learning or what have you, where they're like, okay, well, can we take information we do have and then use that to synthesize what we think sales information in this other region would look like, and then use that to kind of like bootstrap a new effort? That has been one of the really interesting things from us. And I think the cold start problem was one we didn't maybe think was going to be like a really popular thing immediately, right? We were always in the mindset that like, oh, I just have data set A and I want to synthesize a version of it so it's safe to share. But that one has cropped up more and more. Like, how can we be a replacement for something like, there's like libraries like Faker out there. There's like tools like Makaroo, which give you fake data sets, but they don't necessarily come with trends baked in, right? Like, hey, I want to know what like soccer ball sales in New England look like. What if we just had a synthetic model that was already trained on something like that and you could generate data for that? And then I really want to know what it looks like in the months of like, end of the summer before school starts, because everyone's going back to training camps. And then I've already conditioned that model to generate data based off of, a date. So then I can just only focus in on that. And I already know that it's trained on real data. So it's going to be statistically relevant data. I don't have to just like use random number generators to create that. So that's been one of the coolest things I think that we have seen.
In your own experience of building the company and working on the technology, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think one of the most challenging things is we're always on our toes about the different types of data we see. When you build something, you kind of build this like corpus of, I'll call it like fixtures, right? To use a very specific like testing term. And you go through and you test on, maybe we have like 500 to 2,000 different data sets we test everything on, and we're like, oh, cool, like everything works. We think we have a variety of data. And then, every day someone's like, I exported some HL7 data into like really gnarly nested JSON and like I want to process it. And we're like, oh, that's a new one. We have to kind of figure out how to work with that person to kind of pre-process the data and put it through the system. And so I think we're always going to be thinking about the shape of data and how to process different shapes of data. That's one of the biggest ones, like at a granular level. And I think just the consumption and packaging is one that's always top of mind, right? It's very complex to take a complex thing and make it simple to use. And so we're always trying to say, like, how do we go from like 5 keystrokes, 3 keystrokes to 1 keystroke? Long term, we want to see Gretel in the hands of non-developers alike too, right? Like, how do we plug into a Google Sheets? How do we plug into Airtable? How do we plug in? So I just want to, like, as simply as I can go into Google Sheets and share it with you, can I also route it through something like Gretel and get it to you, right? And so now we're pushing up in the consumer stack. And I think that's something that's going to be top of mind and a very complex problem, but I think a very fun problem to solve.
For people who are interested in starting to incorporate privacy engineering and data obfuscation tactics into their workflows, what are the cases where Gretel is the wrong choice and they're better suited either building something in-house or using some open source framework or a different commercial vendor?
I think there's a couple of places where Gretel's the wrong choice. One on the ethical side, if someone's like looking to exploit data and they're using like, hey, can I use Gretel to find ways to like violate privacy almost? Like I'm interested, like, oh, is this a data set I want because it contains PII that I might use to like target customers in an incorrect way? Those are decisions we make as a company, not to like have them as customers. On an engineering level, reversibility, it's not something we're really super interested in, right? When you synthesize a data set and you create a synthetic model and you generate data from that model and you're like, well, I need to actually revert this back to where it was, like that's kind of a one-way door, right? And if you're looking to do that, then, of course, you could stay in Gretel and use some of our transforms that might give you reversibility, like format preserving encryption. But we're not a tool where like you would mask the data and then only certain people can come in and unmask the data and select it, right? There are tools out there like you see like in legal documents where like you redact certain parts, but only certain people have permissions to come in and look. That's not what we're really in the business of. Really what we want to do is like accelerate the way that you can share data and then use that data. So I would, probably recommend other tools when it comes to like selective unmasking of information.
As you continue to build out the Gretel platform and explore the space of privacy engineering and help your customers accelerate that ability to build and share data sets, what are some of the things you have planned for the near to medium term or any areas that you're particularly excited to dig into?
Yeah, I think one of the areas that I'm pretty excited to dig into is how do we kind of put this collaboration ecosystem around data, like the same way GitHub did for Git, right? When I think of GitHub, I don't think of Git per se. It's like the prefix for the whole company's name. I think about like the ability to collaborate on code, like through a rich pull request experience. I see, a way to manage releases, a way to manage, CI/CD now with GitHub Actions. So how do we kind of put that collaboration around data to make collaborating on data like fun and like actual like productive? And so for us, we kind of see this, call it a marketplace, call it a place to exchange models, exchange data, but knowing that like, can I just sign up for Gretel and someone has, created a model that is data that I want? Can I just join their project and generate and data from that, right? That's what I'm really excited about building, is that ability to share data very quickly and like have fun doing it. And, for us, we view Gretel as the processor of the data and then the facilitator to actually collaborate with that data. If I think about platforms like Kaggle, right, where it's like humming and experimenting and learning with machine learning, and then there's the Kaggle competitions that are there. You don't necessarily have guarantees about the data that's there, though, right? We had a blog post a long time ago. We found some old data from, it was like bank loan information, and there was PII like buried way deep in the data set, right? Like there was no guarantee that the data that was there was safe to share. So of course they took it down once we kind of alerted them to it. But, can we have a collaborative ecosystem like that where there's like a certain level of safety when you're there? Because like working with data is scary, right? You're like, oh, someone emailed me this data set, and like open it, you're like crossing your fingers, you don't see social security numbers staring at you or something like that. How do we remove that fear and just make it fun to work and share with data and like just lower that barrier?
Yeah, it's definitely an interesting aspect to the problem.
Yeah. Yeah. I mean, like, I'm like still like, I have spent years working in the government and like sensitive information. And you're always just like, holy crap, what's on my hard disk that I don't know about. Right. But like, if I download the data from Gretel and I want to work with like forecasting data or like technical data, telemetry data, and I download it from Gretel, like I can have like peace of mind that I'm downloading something I shouldn't have.
Right.
The worst case scenario in working in a government was like the FBI is knocking at your door. It was like, hi, we have a record of you downloading classified information you shouldn't have downloaded. It's like, what's our version of that? It's like, you don't want like your risk officer kind of knocking on your door. It's like, hey, like we exported a database dump that like went out to way too many people. And now we have to like take your laptop. So like, that's kind of where I see us going.
Yeah, that's definitely an interesting dimension to the problem where most people are thinking about, what is the risk of producing a data set that has information that I don't want made available? But yeah, there is the other side of it of accidentally coming into possession of data that you shouldn't have. And what are the risks associated with that?
Yeah. I mean, it's the simplest things. Like I have like more junior engineers, not at our company, but like places I talk to. And I was just even talking to my brother who is a developer and talking about like access to data sets to learn other things, right? Or like, hey, like how do I get into that analytics? Like I really want to be able to like get really good at SQL and stuff like that. It's like, what are good data sets for that? I'm like, a lot of good data sets. You probably shouldn't have access to them, but it'd be cool if you go download a data set that's like, here's really good information for XYZ. Go get it from Gretel. And it's safe.
Yeah. Be curious to see how that plays out. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I would like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Well, I think for one, I think there's a gap in the tooling, period, which is, I think, what we're really trying to fill in. And two, I think I say it, maybe I think there's a gap in like a good developer experience when using tools, especially for privacy engineering. They're not always the easiest to get up and running with. A while ago, I talked about that spectrum where it's like you have the big like data loss prevention type tools in the cloud providers, or you have kind of these like new and upcoming like open source tools that are out there. And sometimes you just want to have like a really good developer experience. And, I reference companies like GitHub and Stripe, and they have excellent developer experience. Like, I've built with all of them. I've used APIs from other providers out there like WorkOS for authentication and Auth0 for authentication and Stripe for billing and, Sentry for error handling. And like, you just kind of read through their docs and you're just working with them and you just feel really productive when you're working with them. You're like, wow, I built something like that was really hard, but like this API made it really easy. I think that developer experience is pretty much missing from privacy engineering, right? And that's like, when it comes to building the product, that's one of the things that like I want to make sure other developers like just like have fun using Gretel, like they feel productive.
Absolutely. Well, thank you for taking the time today to join me and share the work that you're doing at Gretel and your overall perspective on the privacy engineering space. It's actually a very interesting and complicated, important problem domain. So I appreciate the time and energy that you and your team are putting into that. And I hope you enjoy the rest of your day.
I had a blast and, I really appreciate you having me on the show.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.